Hi, I'm Alex from Tailscale, and in today's video, we're going to deploy Caddy, which is a reverse proxy. We're going to deploy it, though, on a Digitalocean droplet in the cloud. Now, what's the point of doing that, you might ask? Well, I have a Jellyfin server running in my basement, and those of you that know anything about Jellyfin will know that being a fully self-hosted solution, there is no cloud component. That's in contrast to its bigger brother, Plex. Plex lets us do remote access by virtue of them providing this cloud discovery authentication layer. The downsides are privacy concerns, of course, and also if my internet goes out, I'm not able to access my locally hosted media. Well, Jellyfin solves all of those problems, but in doing so creates other ones. Like, it's up to me to provide that remote access solution. Well, that's exactly what we're going to do today. We're going to use Caddy running on DigitalOcean to proxy Jellyfin running in my basement using Tailscale as a backend connection layer, all using infrastructure as code principles. So we're going to do stuff with Terraform and Ansible, and don't worry if you've never used those tools before, there's links in the description to code snippets and chapters 2 going through all of the details of everything you need to know. I should also add this is part 4-ish in a infrastructure as code playlist that we've been putting out over the last few weeks, going over the real nitty-gritty details of cloud init to pre-authenticate nodes to your tailnet, and Terraform in excruciating detail, and Ansible and all that kind of stuff. So today is really just the final, it's like the final assembly video, right? This is how we take all of those different components and bolt them all together. Whereas in the previous 3 videos that we've done, it's been how do the tools work? Why do we do certain things? So if you've been looking for a way to get started with a reverse proxy and have been put off because it's too complicated, then I think today might be the video for you. All right, so I thought a fun way to kick this video off might be to do a speed run. Just how fast can we deploy all of this stuff when it's pre-configured? I have here a stopwatch, so I'm going to press start on here. And the first command I want to run is just apply. Now in editing, I'm going to obviously leave this clock running, but in editing, I'm going to speed things up a little bit. So the first things first is it's going to go out to DigitalOcean using Terraform to actually create the virtual machine for me. And this is the part of the automation that takes the longest to run. This can sometimes take a couple of minutes because what it's doing is it's creating a Linux virtual machine. It's then installing Tailscale and a couple of other packages, as well as creating users. But then it's also pre-authenticating this node to our tailnets using an auth key. So this can take a couple of minutes to run. As soon as this node appears here in my Tailscale admin console, I'll be right back. There we are, about 1 minute and 43 seconds in. The node now appears on my tailnet. So if I jump back to my VS Code window and type just run Caddy, this is going to have Ansible now reach out over SSH to that remote host. No SSH keys installed. This is all using Tailscale magic under the hood. It's going to configure Caddy for me, and you can see that in real time, in 2 minutes and 15 seconds, Caddy is now configured. So, and of course I had to wait for a moment just for the DNS to propagate up on Cloudflare, but look at that, 3 minutes and 20 seconds, including DNS propagation. Whew. So that is the magic of infrastructure as code. I can spin up a brand new virtual machine completely from scratch in under 3.5 minutes with Jellyfin pre-configured to be reverse proxied through Caddy using just infrastructure as code principles. So make sure you make fastidious use of the chapters down below, because there are lots of different sections to get into to make this little jigsaw work today. But with that said, nothing worth doing was ever easy, was it? So let's move on to configuring our workstation prerequisites, as well as all the other things you're going to need to complete this project. In this section, we're going to cover all of the different prerequisites that you're going to need to complete this project. So first of all, you are going to need your own domain name. Now you can go to Namecheap or Porkbun or GoDaddy or Hover. There's a million different places to buy domain names, but today I'm going to be using Porkbun. So if you want to stick to the script and copy what I'm doing, Porkbun is the place to go. You can typically buy a .com domain name of your own or any other TLD for $10-ish a year or less. It depends on what you go for, of course, but it's not a significant expense, hopefully. Now, the next thing you're going to need is control over the name servers for that specific domain. And if you've just purchased the domain, you almost certainly do have control over not only the DNS for that name, but also the name servers too. Typically in your registrar's panel, alongside where you purchased the domain, there'll be an option for you to customize the name servers for your domain. Now, a lot of these registrars not only let you customize the name server side of things, but also the DNS too. In today's video, though, I'm going to be using Cloudflare, and you're going to need an account with a public DNS registrar too. I typically like to separate out concerns between where I register my domains and where I host a DNS for them. And indeed, all of the code that we're going to be using today is tested against Cloudflare specifically. There's a couple of plugins that we're using to automate SSL certificates, TLS certificates, against Cloudflare specifically. So again, if you want to stick to the script, we're going to use Porkbun to buy the domain and then Cloudflare to manage the DNS. You're also going to need a service to proxy. In our case, we're going to use Jellyfin. This is a self-hosted open source media server. And the reason I picked Jellyfin is because it's quite bandwidth intensive. So if the solution we do today works with Jellyfin, it'll work with anything that you want to proxy using this method. The final thing you're going to need is an account with a cloud VPS provider. Today I'm going to use Digitalocean, and again, all of the code that I've linked in the description down below is tested against Cloudflare and Digitalocean. You can, however, modify that stuff to work with Linode or Hetzner or AWS or wherever you want to host this virtual machine in the cloud. The important thing is really that you have an IPv4 address that is publicly routable, and that way you can access this virtual machine and this reverse proxy from anywhere on the public internet. And finally, you're going to need some kind of a client device to run all of this code from. In our case, I'm going to use a Mac today, and the reason I use a Mac is because it has a Unix or POSIX kind of compatible shell that lets me kind of treat it like a Linux box, but it can also run things like Adobe, and you don't care about all that kind of stuff. But I'm going to show you how to configure a Mac in this next few seconds here. Now, if you don't already have Homebrew installed, you want to go ahead and go to the website brew.sh. Copy and paste the Homebrew installation command into your terminal and get Brew installed. Once Brew is installed, we're going to want to now go ahead and install a few packages. The first of those is doctl. This lets us communicate with the DigitalOcean API programmatically to do things like list our SSH keys and check out the size of different VMs, all that kind of stuff. It's a tool for interfacing with DigitalOcean on the command line, doctl. The next one is Ansible and Terraform. That's because all of the code that we're using today underneath is based on these two tools. So we need to install their tool chains so that they'll actually do anything for us. The next one is Bind, and this is a meta package that actually contains several other networking related packages. In our case, we're going to install Bind because it includes a tool called Dig, and Dig is a DNS inspection tool, which we'll use later on in the video, just to verify that some of the stuff we're doing is actually set up correctly. Finally, we're going to install Just. This is a tool that lets us take a bunch of long, complicated commands and put them onto a single file, like a script almost, but it's a script that we can call certain functions into and out of. Don't worry, that will all become clear throughout the video. So go ahead and install these 5 packages, and when you're done, your Mac is ready to go. So in this section, we're going to configure the name servers for your domain name. Now, the name servers are what tell the internet's DNS registry where to look for authoritative DNS entries. In our case, we want to point this domain name's name servers to Cloudflare. By default, when you purchase a domain, it will probably be pointing to that domain registrar's name servers. And indeed, if we look over on Porkbun, we can see that the default name servers for this particular domain are listed here for us. So what we want to do is go over to Cloudflare, find out what name servers are assigned to our account, and add this website, this URL, this domain name, into our Cloudflare dashboard. So cloudflare.com, get logged in. And then once you're in the main kind of dashboard area, click on this page here which says add domain. And I'm simply going to type in here initech.video. Along here, by the way, Cloudflare is also a domain registrar, but I do like to try and keep these things separate so that all of my domain name registration happens over on Porkbun or Namecheap or wherever. Then all my DNS happens over on Cloudflare or wherever else you choose to do it. Now notice that once we get beyond the initial page here, there are a bunch of different plans we can select. Don't worry, we can just select the free tier. That's more than enough for our needs today. Now, Cloudflare is going to go out and scan the existing domain looking for existing name server entries, all that kind of stuff, just to say, well, what is this domain? What have you given me? Where is the name servers currently pointing? What DNS entries currently exist for this domain already? Now note at the top of the page, it goes through the wizard and does a whole bunch of stuff for you. It says pending name server update up here. So what we need to do is continue our activation process and add our own name servers from our Cloudflare account. So I'm going to click on continue activation at the bottom. And then I'm presented with this little option down here. Number 3 is what we're after. So we want to replace the existing name servers, Machio, these are all fake words. Salvador, that's a real one. We want to replace these Porkbun name servers with our Cloudflare name server entries. So click on here to copy this. I'm going to copy Milani first of all, and I'm going to simply in the Porkbun dashboard, click on this little NS button down here, and then just replace the contents of this text box with what Cloudflare provide for me here. So Milani and Stephen, and then I'm going to click on submit. Now this can take up to 48 hours to propagate, and there's not really a lot you can do about it. I do find Cloudflare tends to happen in 10 to 15 minutes, but it is what it is. It's a one-time deal. Once you buy the domain, set the name servers, you can typically forget it until renewal time, but you are going to have to set these name servers up one time. Remember earlier in the video, I had you install Dig, and this is a DNS querying tool. Well, we're going to use it here to actually figure out what the name servers for initech.video are currently pointed to. So if I do dig capital NS and then the domain name that I want to query, you can see that these are all currently pointed at Porkbun. Now that propagation, as I say, can take 48 hours. Typically, I find it takes 10 to 15 minutes. Now, if we do it for a different domain, for example, I think I've got Initech labs.dev. You can see here that I've got these name servers appointed to my Cloudflare account. So it will just take a moment to update and propagate, but that is how you update your name servers. Later on in the video, we're going to come on to configuring the Jellyfin specific entry. But for now, that is all we need to do with DNS. In this section, we're going to deploy Jellyfin, the open source media server. We're going to do that on top of Ubuntu, which itself is running on top of Proxmox. So it's a little bit Inception, but essentially what we're going to end up with is an instance of Jellyfin running in a container that we can access on a dedicated IP. And we're going to then put that on our tailnet when we're done. So first thing we need to do is go to the Git repo that's linked in the description down below and clone that anywhere we like. I'm going to choose my local laptop because we're going to use it several times throughout this video. So Tailscale-dev video code snippets. Once we're there on GitHub, I'm going to click on this green code button over here on the right hand side and just copy this URL to my clipboard. Next, in my local laptop, this is the MacBook I'm using to record this video called Baldric, I'm going to do make dir and then Tailscale temp. You can call this whatever you like. The actual name doesn't matter too much. Then change into that directory, followed by git clone, and then the name of the repo using the URL that we just put onto our clipboard. Now I'm going to use this command here, code video code snippets, to open my Visual Studio Code editor in the right directories for us. Now we want to go straight to 2024-07 Cloud Init and then 02 Cloud Init do Terraform. In here is a compose YAML file. This is what we're going to want to use to deploy Jellyfin. Now the Ubuntu virtual machine that we're going to use to host Jellyfin is already on my tailnet, and I also enabled Tailscale SSH. It's called fake NAS, and this means I don't have to worry about SSH keys or anything like that. You'll see more about that when we create the cloud resource in a minute. But essentially fake NAS is a virtual machine running in my house behind a residential firewall. No ports open to the public internet. There is no way for you outside of this building to access this virtual machine. And that's what we're going to solve with Tailscale. So If I do a Tailscale status, we can take a very quick look and see all the different devices that are on the tailnet that this virtual machine has access to connect to, or vice versa. We want to create a new file in the home directory of the primary user. I mean, you can put this file anywhere, but I'm just going to put it in the root of the home directory for my primary user on FakeNAS. And we're going to call this file compose.yaml. It has to be docker-compose or compose.yaml in order for Docker Compose to pick this file up. So the name of this one does matter. Open this file in your favorite editor of choice, and then just copy and paste the YAML file from the Visual Studio Code window into your virtual machine. Now, there's a couple of things to note. The app data, so this is the stuff that Jellyfin uses to store things like artwork and a bunch of other stuff. This must persist, and this is a fairly standard Docker concept beyond the scope of today's video. Also, we want to make sure that we've got access to our media. So I went ahead and mounted via Samba the TV shows directory that has all of the media files and things stored elsewhere on my network. I went and added that via Samba to this virtual machine so that we actually got some videos to watch. And that's what this mount JBOD section is over here. Beyond that, you want to make sure your published server URL and your time zone, all that kind of stuff match. Also, we're not going to need this in the long term, but in the short term, the ports is going to be useful for us to have exposed as well. So just remember 2285. We'll come back to that a little bit later on in the video. This published server URL, as I say, must match the eventual URL that we're going to use by the end of this video. So in our case, that's going to be jf.initech.video. Once you've got that all configured and you're happy with it, go ahead and save that file and then do a docker compose up. And you can do up without the -d or with the -d is to run it in detached daemon mode. It'll go and pull the Jellyfin image from Docker Hub and then start running the Jellyfin container. So I'll do a docker compose logs -f to follow the logs in real time for Jellyfin. And we can see that everything here looks mostly fine. There's not a lot really of sense I can make of these logs right now, but what we've done is deployed Jellyfin. So let's just go and verify that. If I refresh this page now, we can see that FakeNAS :2285, remember that port number from before? This is now running on that local Ubuntu virtual machine, and I can access this anywhere that I'm on my tailnet. So if I was to grab my phone, for example, and open Jellyfin on this at the coffee shop, and I'm connected through Tailscale on my phone, we don't need any of this reverse proxy cloud stuff that we're about to show you throughout the rest of this video. All we need is to have a connection from my tailnet through this phone across the public internet with a direct connection back to this virtual machine running in my basement. The entire purpose of doing this with a reverse proxy is to expose this service to the public internet. So just be careful. The public internet can be a dangerous place, and I don't mean to fearmonger at this point, but this probably isn't a solution you want to leave exposed to the public internet 24/7. I mean, you certainly could, but more often than not, what I tend to do is spin this up for a few days whilst I'm taking a trip and want external access to my Jellyfin on hotel Wi-Fi, and I don't have the ability to have the client device directly connected through Tailscale natively. That kind of thing. All right. So the idea behind this entire video is just to make you think, I'm connecting a cloud front end, Caddy in this case, to a private backend, Jellyfin, with Tailscale as the connecting fabric underneath through an encrypted WireGuard tunnel. This is a little bonus tip. If you have the VS Code Tailscale extension installed, you can click on the Tailscale button on the left here, and it will show you all of your different Tailscale nodes. We can actually then go and modify files on those remote nodes directly from VS Code. So I'm going to bring up this compose YAML file. This is on the remote host look, FakeNAS, home, Alex compose. This is the exact same file that we just modified in the terminal over here. It's just really up to you whether you want to use the VS Code extension or whether you want to do it through a terminal editor like I did. All right, now we've gone and deployed Jellyfin, it's time to go and generate all of our different API tokens from across the web. In this section, we're going to generate the 3 different API tokens that we need from across the web. First one is the Tailscale auth key. So let's jump over to tailscale.com, go to the admin console, under there, get logged in using your authentication provider of choice, click on settings, and then on the bottom left-hand side down here, click on keys. Next, I'm going to generate an auth key and then call this whatever, banana test 123. The name is totally optional and irrelevant. Because this is a demo, or I'll be spinning things up and down a few times, I'm going to click reusable. You might want to do this as well if you just want to spin this solution up and tear it down a few times. Totally up to you. Now I'm going to click on generate key, and this will only be shown once, so make sure you copy it now. I'm going to copy this to my clipboard and go back to VS Code. In VS Code, we want to put this into a specific place. In the Terraform directory, there is an auto tfvars.example file. We want to rename this file from .example to just .tfvars. That's so that Terraform picks it up correctly. Then copy and paste the value from the Tailscale admin console into this tfvars file. Next, we want to go to Digitalocean, get logged in again, and generate ourselves an API token so that we can spin up virtual machines and destroy them and create resources against our billing account on Digitalocean. Down here on the bottom left-hand side, there's an API option. Click on that, and then we want to generate ourselves a new token. This one I'm going to call bananafish123. If you are doing this in production or being super serious, you can generate a custom scoped token. I'm a little bit lazy and I want to keep things simple today, so I'm just going to click on full access and generate myself a full access token. Again, this will only be shown one time, so make sure you copy it here and go back to your VS Code window and just paste this into the tfvars file that is there. In terms of the Terraform files we need to modify, that's it, but we do need one more token, and that one is going to be from Cloudflare. So let's go to cloudflare.com, get logged in once again, and up here in the top right hand corner under my profile, go to API tokens on the left hand side. Now you can see here that I've got a token I already generated for a previous video. So the important thing is that this needs to have the following permissions: zone.zone and zone.dns. So let's go ahead and actually create that token from scratch. So I'm going to get started with a custom resource. I'm going to give it a initech.video, I think is the URL we're using. So on this first line, we want to do zone and then zone again, scroll right to the bottom and check zone. It's quite a long list. So zone down here and then select read. And then the next permission we want to grant is again zone and then DNS and then edit. This is so that the TLS challenge that we're doing as part of our Ansible deployment for Caddy can have permission to connect into Cloudflare via the API and verify our ownership and therefore our identity for ownership of the specific domain in question. Now, when I click on continue to summary, I'll be brought to this page, which is going to create the token for me. Now, I'm going to copy this to my clipboard. Again, this will only be shown once, so make sure you take a note of it at the appropriate time. And under Ansible this time, we're going to go into vars and secrets. Now this secrets file is currently my example secret, so we're just going to go ahead and clear this out completely. At the beginning of an Ansible variables file, it's good practice to put 3 hyphens. And then we want to create Cloudflare underscore API underscore token, and then just paste in the value that we generated on Cloudflare a moment ago. When that's done, click on save, and don't worry, we won't put any of this stuff in GitHub unencrypted. I'll show you how to encrypt this a little bit later on. But in terms of generating API tokens, we are now good to go. It's time to move on to the basics of creating our cloud VPS machine using Terraform. In this section, we're going to create our Cloud VPS instance on DigitalOcean using Terraform, which lets us do it programmatically. But in order to do that, there are a couple of things we need to take care of. And the first of those is listing the SSH keys that are on our DigitalOcean account. And that's because when we create the virtual machine, typically it either wants you to supply a root password or supply an SSH key. It's nothing to do with Tailscale, it's just a way that DigitalOcean works. So what we need to do is use this doctl command. Remember, in the prerequisites at the beginning of this video, I had you install a couple of things and doctl was one of them. Well, this is where we use it. So we want to actually, first of all, grab our do token once more. And we actually have this stored from one of the earlier steps. So it starts dop underscore v1. I'm going to put that onto my clipboard. And then I want to jump to my terminal window over here. And the command that I need is doctl on line 22, doctl-token, and then compute SSH key list. Now this does presuppose that you have SSH keys already set up on your DigitalOcean account. If you don't, go ahead and create them in the, where is it? In settings, I think down here, settings, and then security, add SSH key over here. You can see I've already got a couple, one for the laptop behind me, Magrathea, and one for Baldric, which is the one that we're using to record this video. What was the command I needed? SSH key list. Okay, so jump back a second. doctl, provide our token with the -t, and then compute SSH key list. What this will do is it will go to the DigitalOcean API and say, excuse me, what SSH keys does this account have assigned to it? And it will provide you with a list. In my case, I've got 2 SSH keys added, and you can see that 42950830 is the one that's assigned to Baldric. Now you can see that in my Terraform code here, I've actually got that exact same number, 4925 over there. You can go ahead and customize any of this stuff at the moment. This is just a basic $6 a month, super basic droplet. You don't need more than that for just a reverse proxy, although you certainly could if you wanted to. Along with the name and the image, I'm using Ubuntu 2404. All of this stuff here can be customized to fit your needs, but this is just what works for me for this video. Do not change the user data line though, because that will break stuff. Just modify the SSH key thing and these lines up here. Right, now we've got the SSH key thing taken care of, we're actually ready to create the virtual machine. In VS Code, you can bring up the integrated terminal by pressing Control and then the tilde key, or the top left sort of backtick key. Certainly on a Mac, that's the one next to the number 1. Anyway, top left, underneath Escape. I'm going into too much detail on where to find a specific key, but here we are. I'm using, remember in the prerequisites at the beginning of the video, I had you install doctl as well as just. Well, this is where we're going to use just. Here is a just file, in fact, and this contains a set of instructions that we're going to use to run Terraform and Ansible commands without having to understand any of it. Now, the first one that we need to do is actually change into the correct directory. So first of all, we want to go into 2407 and then 02 cloud init do terraform. This is so that we're in the correct context in terms of the directories that we're in for just to actually pick up the just file. So what we want to do first of all is run just init. And what this is going to do is it's going to set up Terraform for us to run against DigitalOcean. In effect, it's going to install what's called a provider, which is a translation layer for how Terraform speaks to DigitalOcean. Once that's done, you should see a whole bunch of green text. We can now do just apply. It's then going to spit out a huge long list of things it's about to do. It's going to create a machine with all of these parameters. You can probably just type yes. Now, Terraform's going to go out to DigitalOcean and create us a virtual machine. In the background, it's going to inject what's called a cloud init file, which is going to install Docker, first of all, and then it's also going to install Tailscale and also pre-authenticate this virtual machine to our tailnets. So in essence, what that means is that with these 1 or 2 commands, we've created our cloud virtual machine and it's already on Tailscale. We don't have to do anything else. And indeed, if we jump over to the DigitalOcean console, we can see that we now have a brand new virtual machine called NYC Terraform Caddy. Now, it will take a couple of minutes for this virtual machine to boot, install the Tailscale and Docker packages, and do all of the tailnet authentication type stuff. But once it's there and ready to go, if you jump over to your Tailscale console and just refresh, literally, it will only take a couple of minutes for the most part. You'll see that this node now appears in your tailnet. And because we enabled Tailscale SSH as part of the automation using Cloud Init, we can actually just SSH to this machine as well without worrying about SSH keys even. So I can do SSH root at NYC1 Terraform Caddy and voila, it worked. So we have a completely blank virtual machine. There's absolutely nothing going on here. I think because it's such a brand new system, it might be doing the automatic security updates that Ubuntu likes to do as part of the unattended upgrades. But that's it. You just use Terraform, maybe for the first time, I don't know, with a couple of commands to create a virtual machine up on DigitalOcean. Couple of housekeeping things you might want to do. You might want to update your repos just to get the latest, freshest packages, all that kind of thing, with apt update followed by an apt upgrade, and then reboot the machine. Now, while you're running the upgrades, you might see a screen that looks like this. If you're not sure what to do, just select the option that says keep the local version currently installed. That will have been tweaked probably slightly by Digitalocean or some of the automation that we ran. The last thing we want to do is go right back to a vanilla stock configuration and lock ourselves out of the cloud VM. So I'm just going to select keep the local version currently installed before I move on. Once you've done that, you've got a completely blank canvas and we'll be ready to move on to running Ansible to configure Caddy as your reverse proxy. Once all the upgrades are finished, I want to just verify very quickly that everything looks good from a Tailscale perspective. Remember, we're already connected in through Tailscale SSH anyway, so this is probably a little bit superfluous, but by typing Tailscale status, this lets me verify all the other nodes that this one can see as its view of the Tailnet world. Now, if I want to verify a direct connection from this system, so remember this is running on Digitalocean in a data center in New York, and I want to connect back to Fake NAS, which is running in my basement here in Raleigh. This is how the entire reverse proxy thing is going to work, remember, a direct connection across the internet through a Tailscale encrypted WireGuard tunnel. I can do Tailscale ping and then Fake NAS. And what this is going to do is it's going to bounce out to what's called a derp server. This is a Tailscale specific thing. It's then going to bounce out to that derp server, go back to Fake NAS in my basement and use that coordination server to then establish a direct connection underneath. So as we can see, Tailscale ping established a direct connection back to Fake NAS. Now remember, what's cool about that is that Fake NAS is running in my basement behind a residential firewall with no ports open. So this cloud VPS is able to reach from where it is over my tailnet using an encrypted connection back to my basement. So this is how Caddy is going to proxy Jellyfin running in my basement. So let's get the Ansible stuff done next and then actually start doing our reverse proxying stuff, shall we? So in this section, we're going to actually deploy Caddy, and we're going to do this using Ansible. Ansible is a tool that lets us configure infrastructure. So Terraform's really good at creating stuff like we just did, and Ansible's really good at configuring it like we're just about to do. But before we do that, I want to make sure that we encrypt the secret that we used for Cloudflare earlier on. And in order to do that, we need to create a password file. So in the root of the Ansible directory, I just want you to go ahead and create a file called .vault-password. In here, you can put whatever you like. This will not go onto Git, and that's because I have it set in this git ignore file down here. You don't need to understand a lot of this stuff. Just hopefully take my word for it and read the code and understand it later. But the contents of this vault password file are essentially the password we're going to use to encrypt your secret that gets put on GitHub encrypted in a safe fashion. So I'm just going to, for today, use Tailscale 123. Of course, you want to use something more secure than that, but this will certainly do for our quick demo today. Now, in the just file, again, and the reason I keep going back to some of these more technical things, even though this is supposed to be a beginner-friendly guide, is just to try and level you up and take you along for the ride in some of this stuff that we're doing. This just file is basically a hymn sheet of instructions of what we're trying to do today. So we've already done the init and the apply. We're not going to do the destroy, hopefully, unless something goes wrong. You'll see that we do run and rex in just a minute, but for right now, we're going to do vault. And we use vault whenever we want to encrypt or decrypt or edit any of our secrets so far as Ansible is concerned. So to encrypt the contents of our secrets.yaml file, I'm going to do just vault encrypt. I'm going to bring that file up for you so you can see it encrypt in real time. So right now, that's what this file looks like. And as soon as I type just vault encrypt, you can see that the file gets encrypted in real time using that Tailscale 123 password that we set in the vault password file. And just as the same way as we encrypted it, we could decrypt that too if we want to make a change or whatever. There's also an edit file, edit mode if we want to do that too, but I tend to just use encrypt and decrypt. All right, so with that done, the last thing to do before we go ahead and actually run the Ansible side of things is, remember how with Terraform we did init to set that up? Well, we need to do the same thing with Ansible. And in this time, we're going to use just Rex, R-E-Q-S. That's going to download the Caddy role from GitHub that I've written for this demo. That's the thing that installs and deploys Caddy to your VPS, as well as configures it with some of our group variables, which brings me on to the last thing that we need to configure before we go ahead and run the Ansible code. Now, I've written some code in the Ansible role that handles a lot of this stuff for you, but we do need to just specify a few things. And one of those is specifying the domain that we're going to use. So in my case, that's jf.initech.video. We also need to set the upstream URL. So that's what the Digitalocean VPS is going to be connecting to over Tailscale. Now remember, right at the beginning of the video, I showed you fake NAS 2285 running Jellyfin. Well, that's the exact same way that Caddy is going to connect back into our instance as well. We don't need to use TLS insecure false because Jellyfin is running as an HTTP connection. And for the TLS provider, we're going to use Cloudflare. So it's worth mentioning at this point that this role is written and designed to work with Cloudflare as the DNS provider. That's because of the way that Caddy works with some of its DNS challenges and that kind of thing. If you want to modify this and make it work with another provider, you absolutely can, but this is only written to work with Cloudflare as it stands today. One final thing before we go ahead and run the code is we just want to make sure that this hosts file here matches the name that if we changed anything in the Terraform file earlier on, the username matches, and that the host name, so NYC1 Terraform Caddy, this is the host name of the droplet as far as it's concerned on your tailnet, because we're going to use Tailscale SSH to authenticate to this remote node as well. So just make sure that's all hunky-dory as well. And now I'm going to do just run Caddy. And hopefully, if all goes to plan, at the end of this, we will have a working Caddy instance on DigitalOcean. So in order to verify that we have that working instance, we're going to just use SSH. I'm going to jump over to my terminal over here and SSH to root at NYC1 Terraform Caddy. This is the host name in Tailscale, because we're going to use Tailscale SSH to make this SSH connection. So it must match what's in your Tailscale admin console. We're going to SSH to this remote host and check out a couple of things. So systemctl status Caddy. Systemctl is a tool that lets us look inside the Linux operating system and see what different services are up to. In our case, this is the Caddy service. I'm going to add a -L onto the end of mine because I noticed a couple of errors just here, and just inspect them and just see we've got some what look like client-side issues, aborting with incomplete response. So it's nothing to do with the TLS certificate generation and that kind of thing, which is the thing I actually care about. I don't care too much about client-side errors. I care about if the TLS certificate isn't being generated for some reason. So that all looks good. Caddy is running and there are no errors that are causing me great alarm. But let's just verify that the Caddy file was written correctly. This is the set of instructions that Caddy uses to proxy all of our different traffic. So I'm going to use a tool called cat, which prints out the contents of a specific file. And I'm going to cat the contents of the file /etc caddy, and then with a capital C caddy file. This is all case sensitive, so it does matter to put the capital C in here. I'm going to cat out the contents of our caddy file, and just note that the Ansible code has gone ahead and installed the Cloudflare TLS DNS challenge stuff using the token that we specified earlier in the video. It's also gone ahead and added in a stanza for us to proxy traffic that it receives on jf.initech.video. So it's worth saying at this point that this is how a reverse proxy works. It listens for a request coming in with this URL baked into its headers as part of the request and goes, oh, that means you want to receive this specific resource. Now we've given Caddy permission to go and get that resource from fake NAS. In our case, it's a Jellyfin component. And we're proxying that over Tailscale on the back end. So whenever I make a web request to jf.initech.video, it's actually going to fake NAS in my basement, even though this request is being served from New York. I hope that connection is starting to make sense for you. So I think it's time to move on to the DNS configuration now. Now, if you've made it this far in the video, we are super close. The last thing we have left to do is to configure our DNS in Cloudflare to point to our reverse proxy. So we're going to need a couple of pieces of information. First of all, make sure we're logged into our Cloudflare dashboard if we're not already. Go to the domain in question, so initech.video. On the left-hand side, click on DNS, and we're just going to add a simple A record. And we're going to point this at jf.initech.video. I want to turn off proxy status, but I need the IPv4 address of the DigitalOcean droplet. So this is the public IPv4 address. So this one here, 67.205. And I'm going to put that into my Cloudflare dashboard and click on Save. This will likely take a couple of minutes to propagate, and we can verify what's going on as the world sees it by opening up a new terminal. This is a local terminal on my MacBook, and typing dig, and I'm going to do jf.initech.video. So I'll talk you through what happens here. You can see actually it has already propagated. We can see that jf.initech.video now points to 67.205. And so with all of that done, let's go and try it out, I guess. jf.initech.video. It works. I've been doing this stuff for years, and it still amazes me when all of these different pieces of a jigsaw fit together. So let's just get ourselves logged in. What user did I create? Was it Zaphod on this one? Yes. And let's try and remember, this is all streaming through DigitalOcean, and I'm going to make sure I'm muted so I don't get a copyright strike. And I do love me some Michael Portillo. I know I said that in the last video too, but there we go. Direct connection through Tailscale, and it's streaming the video from here in Raleigh back up to New York, and then back to me through, you know, in this situation, it's a bit of a contrived example, but I think that you should get the idea now that this is really going to open Pandora's box for you in terms of a cloud-hosted front end talking to a privately hosted back end. I mean, you could do this with a Synology web UI in a remote country, for example. I mean, once you have this Caddy reverse proxy running on DigitalOcean or Linode or wherever else, Hetzner, wherever else you want to run it, you can then use Tailscale to connect that reverse proxy to any service that you own. And remember, if you're already on your tailnet, you don't need to do this publicly. You could just have this running as a private IP address, not expose any of this stuff to the public internet at all even, and still have it on a real domain with TLS and all the security benefits that that brings as well. If you made it this far in the video, thank you so much for watching, and let me know down in the comments what you want to see us work on next. What tutorials do you want to see? What Tailscale questions do you have? Let us know down below. Until next time, thank you so much for watching. I've been Alex from Tailscale.